While sediment is usually pretty constantly deposited around the world, there will be periods of time where either sediment isn't deposited or it's eroded away. So when we look at the rock record, we're actually missing layers of Earth's history. And that's what this video is going to cover on unconformities. Ideally, all rocks would be conformable. This is just layers of rocks that have been deposited without anything interrupting the deposition of all the sediment or rocks. But we don't have an entire history of Earth's history. We don't have rocks from all of Earth's periods. Instead, what we have a lot of are called unconformities. This is where there's going to be a break in our rock record. For some reason, deposition stopped in the area. We stopped burying new sediment. Then erosion happened. That erosion weathered away the sediment at the top and carried it somewhere else. And then deposition continued on top of that. So when we actually look at the rock record, what we see are missing rock layers. Sometimes those missing rock layers are going to be pretty obvious. Other times it's going to be pretty difficult to figure out that we're missing some layer of rock. But there are going to be three different types of unconformities that we will cover. And the first is called an angular unconformity. With an angular unconformity, here we have two different layers of sedimentary rock that are at different angles from one another. If we look at the image on the right, on the bottom, we have nearly vertical rock layers, while on the top half, we see that the rock layers are tilted up towards the right. So here, because our sedimentary rock layers are at very different angles, we call this an angular unconformity. Something happened that caused deformation during the time that the deposition stopped from new sediment. So what happened here is that bottom layer was originally horizontal. Then some kind of deformation stopped and caused it to be vertical. And then eventually over time, that upper layers of rock was deposited on top of it. But not all of our unconformities are as obvious as our angular unconformities are. Again, with those, we're just looking for changing angles between different rock layers. A more difficult type of unconformity to notice is called a nonconformity. And the thing to look for here is what kind of rocks are above and below the missing rock layer. When we have igneous or metamorphic rocks beneath the missing rock layer, and then sedimentary rocks directly on top, we know that we're missing a layer of rock here. And that's because most of our igneous and metamorphic rocks form deep beneath the surface, whereas sedimentary rocks form directly on the surface. So we would never see igneous and metamorphic directly overlain by sedimentary rocks, because usually there are miles of rocks between them. So if we see that we have sedimentary directly on top of igneous or metamorphic, something has happened. We're missing a lot of rock layers between where these types of rocks form. So we know we have a nonconformity, just because those types of rocks don't form side by side. And our third type of unconformity is called a disconformity. And this one is the most difficult one to recognize. And here, above and below the missing rock layer, we have sedimentary rocks. So if we're just looking at the rocks themselves, we are not going to even notice that we're missing a layer. We're not going to know that we have a disconformity, where we have a gap in our sedimentary rocks, until we eventually start absolute or radiometrically dating this, so that we can actually have a numerical age for each rock layer. Then it'll be obvious if we're missing, say, 1,000,000 years of rock. But again, this one is the most difficult out of our three unconformities. But when we look at a general type of outcrop, when we can see hundreds, if not thousands, of layers of rock in one area, in places like the Grand Canyon, we're going to see all three types of unconformities develop. So here along the bottom, we see nonconformities. Here, because we have schist and granite, we have igneous and metamorphic rocks directly underneath sedimentary rocks. Because these cannot form in the same environments, we know we have a nonconformity. We're missing a significant layer of rock between these. If we look a little bit higher than this, though, we're going to see an angular unconformity develop. This one is the most obvious because we're just looking for rock layers that are at different angles from each other. And then at the top of the Grand Canyon, we have our disconformities. And again, these are the ones where we're just missing a layer between two different sedimentary rocks. Very difficult to notice just by looking at it, but if we actually go through and radiometrically date it, we can figure out that we're missing a rock layer here. For this slide, we're going to figure out the geologic history of just a made-up area by looking at those different principles of relative dating. We're going to move clockwise, starting with part 1, and then end up at number 6. But in part 1, we're going to see that we have deposited layers of sediment, and using that principle of superposition, we'll see that A is the oldest because it's at the bottom, and that E is the youngest because it's at the top. But if we look at number 2, we're going to see that we have an igneous intrusion. We have a sill, which is letter D, come in and intrude between C and E. After this, in number 3, we'll see that another igneous intrusion came through. This is a dike. This is the one that cuts across multiple rock layers. And we're looking at it, we can tell that the dike is younger than all of the layers that it's breaking through based on that law of intrusion. In order for dike F to be able to break through layer E had to exist first before that igneous intrusion could intrude inside of it. But if we go from 3 to 4, we'll see that now all of these layers have been tilted. They've been deformed from their original horizontal layers. And going from 4 to 5, we're going to deposit more sedimentary rock on top of it from G, H, I, J, and K. And we're going to have an angular unconformity develop. Here, this is happening because we have erosion. We have missing rock layers between these types of layers. And then finally, in number 6, we see that more uplift has happened. Literally, this entire area has been lifted up farther above the surface of the earth, and it's starting to be eroded at that very uppermost surface level.